The narrative you're being sold right now is one of scarcity. You hear that AI data centers are going to overwhelm the power grid, that electricity shortages will slow the next wave of technological progress, that artificial intelligence is colliding with physical reality. And once again, the headlines are focusing entirely on the panic. And once again, they are missing the deeper structural signal. But this time, missing it could mean overlooking one of the largest infrastructure investment cycles of the decade. Software scales in milliseconds. A new AI model can reach millions of users almost overnight. But physical infrastructure does not scale in milliseconds. It requires power plants, transmission lines, years of construction. For the last 2 decades, the technology sector generated extraordinary wealth inside the digital world. Many began to believe that software had escaped the constraints of the physical world. But the cloud computing never escaped physics. The cloud runs on electricity, and today, the digital economy is colliding with a reality it can no longer ignore. According to the International Energy Agency, overall electricity consumption from global data centers is set to roughly double by 2030. But if you look closer at the data, the true acceleration becomes clear. Power use specifically linked to artificial intelligence is poised to triple. This isn't because the world suddenly needs more websites. It's because intelligence itself is becoming an industrial process. Every AI model, every autonomous agent, every inference request, every digital worker consumes energy. And while software can scale instantly, energy infrastructure cannot. The challenge is not a shortage of capital. Big tech capital expenditure crossed a massive $400 billion in 2025 and is projected to skyrocket by another 75% this year. The challenge is an acute shortage of capacity. In major power grids, new generation projects are trapped in a massive backlog, facing interconnection wait times stretching anywhere from 3 to 7 years. The bottleneck is no longer computing power alone. Increasingly, it is access to electricity. Consider Northern Virginia, the largest data center hub in the world. The challenge is no longer whether companies want to build more compute. The challenge is whether enough electricity can be delivered to support it. The bottleneck has moved from software to infrastructure. This is where most people make a critical mistake. They see a bottleneck and assume it represents a ceiling. History often shows the opposite. Bottlenecks create investment cycles. Railways created demand for steel. The automobile created demand for roads, oil, and logistics networks. The internet created demand for fiber optic infrastructure. And artificial intelligence is creating demand for energy. This is not simply a technology story. It is an infrastructure story. The immense power requirements of advanced computing are exposing decades of underinvestment in critical systems, and in doing so, they may become the catalyst for a new industrial expansion. Capital is no longer flowing exclusively into software. It is increasingly flowing into transmission networks, power generation, grid modernization, advanced engineering, energy infrastructure. The bottleneck is real. But throughout history, the greatest investment opportunities have often emerged precisely where capacity failed to keep up with demand. AI may be no different. Now, this is not a simple or linear story. AI models are becoming more efficient, and some analysts argue that efficiency gains could offset a portion of projected demand growth. Furthermore, the infrastructure build-out itself faces brutal real-world constraints, from severe capacity auction shortfalls to regulatory permitting delays. But even accounting for those variables, the structural direction appears clear. Tech giants can no longer rely on traditional public utilities. They are being forced to buy power plants outright or build their own on-site generation. The physical layer of the digital economy is being rebuilt. The question is not whether this transition is happening. The question is how fast and who captures the value. Consider what happens next. To support the next generation of artificial intelligence, the world will require unprecedented amounts of reliable, continuous power. Existing grids were not designed for concentrated clusters of hyperscale data centers, which means this transition is not simply an upgrade. It is the construction of a new physical layer for the digital economy. The implications are significant. The winners of the AI era will not be limited to software founders or chip designers. They may also include the owners of critical infrastructure, the builders of energy systems, the operators of transmission networks, the producers of strategic commodities, the firms that provide the physical foundation on which artificial intelligence runs. If you view artificial intelligence only through a software lens, you may miss one of the largest capital migrations of the coming decade, because the cloud is coming back down to earth, and that changes where value is created. This is only the beginning of the story. In this first briefing, we've mapped the bottleneck. Next week, in Part 2, we'll examine the corporate metamorphosis already underway. Why are some of the world's largest technology companies suddenly investing in energy infrastructure? Why is nuclear power returning to the center of the conversation? And why are hyperscalers increasingly behaving less like software companies and more like industrial operators? The old formula suggested that the future would be purely digital. The new operating system suggests something different. The future belongs to those who understand how digital intelligence and physical infrastructure converge. This is the Pivot Compass. Subscribe, position yourself where structural momentum is building, and start preparing for the physical layer of the AI economy.